Good afternoon, student. This is the lecture number 20 of unit number 3, that is strain gauges. Okay, so till now, up to previous lecture, we have studied all the instrument used for the measurement of pressure. In that, we have studied low pressure measuring devices, high pressure measuring gauges, and medium pressure measuring gauges. Okay, so one dead weight pressure gauge is remaining. We will complete that one and then move to the strain gauges. Okay, so the pressure gauge calibration. This is the dead weight pressure gauge. Okay, you might have observed initially, this is the type of dead weight pressure gauge. Okay, so it is basically works on the Pascal law. So here in the diagram we can observe that uh, on the right side there is a piston pump. On the right side there is a piston pump. uh, that piston pump is connected to this reservoir, oil reservoir, then check valve. Here is the check valve, then uh, which is measured by using the gauge under test, means the pressure of that fluid present in the this instrument, that is measured by gauge under test. Then there is one vertical cylinder and piston. Above that piston there is one platform, and on that platform the weight is uh, placed. Okay, so how it will work? As soon as we will insert the plunger, or what we can say that piston, into the downward direction, whatever the fluid present into this dead weight pressure gauge, that will be lifted in the upward direction, and it rises the weight here. Okay, so in the working of the dead weight pressure gauge, the dead weight tester is a primary standard for pressure measurement. Okay, this is the basic, or we may call it as a primary standard for the pressure measurement, and it offers a good calibration facility over a wide range of pressure. Means the instrument having means the instrument have to calibrate. For that purpose, it has a very wide range of pressure means facility, calibration facility over a wide range. Okay, over a wide pressure range. That pressure range is 700 Newton per meter square to 70 mega Newton per meter square. 70 mega Newton, here we can observe 70 means 700 Newton per meter square to 70 mega Newton per meter square. This is the wide range of pressure for the calibration facility. Okay, then gauge in step as well as 0.01% of range with a calibration or uncertainty of 0.01 to 0.05% of reading. Means this is the calibration uncertainly, okay, of the reading. The typical gauge is schematically shown in the figure. Okay, in the construction it consists of an accurately machined bore and finished piston, which is inserted into a close fitting cylinder, both known as a cross section area. Okay, so this is the cross section area. This is the cross section area. In that cross section area, the accurately machined, because once we have manufactured the piston, there will be machining is important for the obtaining the good surface finishing. Okay, then bored and finished piston, which is inserted into a close fitting cylinder, both of known cross section area. Both is having a known cross section area. A platform is attached to the top of the piston. Okay, this is the piston, and on that piston, or on the top of the piston, the platform is attached. Okay, and it serve to hold standard weight of known accuracy, and it serve to hold the standard weight of uh, known accuracy. Okay, so this is nothing but the construction of that dead weight pressure gauge. Then the chamber and the cylinder are filled with a clean oil, which whatever the chamber we have observed in this diagram, which is filled with a clean oil. Okay, and the oil being supplied from an oil reservoir provided with a check valve at its bottom. So whatever the reservoir is provided there, this is the reservoir which is filled with a clean oil. Okay, and that reservoir will be provided with a check valve. Once the that oil level will reduces, the check valve will get open, and the oil present into the reservoir, it will be released into the chamber. Okay, then okay, the oil is withdrawn from the reservoir when the pump plunger execute an outward stroke, and it's forced into the space below the piston during inward motion of the pump plunger. Okay, so what is the meaning? That oil is withdrawn from the reservoir when the pump plunger executes an outward stroke and is forced into the space below the piston during inward motion of the pump plunger. Okay, working for calibrating a gauge, means for the calibration of a gauges, an appropriate amount of weight is placed on the platform, means appropriate amount of weight is placed on that platform which is attached to the piston, and the fluid pressure is applied until enough upward force is developed, means until and unless the enough upward force, the pressure is applied by the plunger, means on the other side, means the what is saying that the fluid pressure is applied until the enough upward force is developed to lift the piston weight combination, means whatever the here a known quantity of weight is placed here known quantity of weight is placed on the platform, and piston pressure is applied from other end until and unless that known quantity of weight will be lifted, okay, by a certain amount. When this occurs, the piston weight combination begin to float freely within the cylinder. When this applied, means the combination of a piston weight is lifted by a certain amount by the application of applied fluid pressure. So when this occur, means when that what we can say, that fluid pressure will applied, the piston will become lifted, and this will occur, the piston weight combination begin to float freely within the cylinder. Piston weight combination is freely float within the cylinder. Okay, under this equilibrium condition, the pressure force is balanced. Under this, means when this will happen, the pressure force is balanced against the gravity force on the mass m of the calibrated masses. Okay, and plus the piston and the platform uh, against a friction force. Okay, so this is nothing but the lifting of the platform and weight piston weight combination. If A is the equivalent area of piston cylinder combination, means whatever we have seen in this previous diagram, that is the area, this is the area. Okay, which area is this? The equivalent area of the piston cylinder combination. The piston cylinder combination area is represented by A. Then uh, the effective or equivalent area depend on such a factor as a piston cylinder clearance, the pressure level, temperature, and is normally taken as mean of the cylinder and piston area. The gauge under test is attached. The gauge under test is attached to the tester, and the pressure P is exerted on the fluid by the piston. Okay, means what we can say, that the gauge which is to be calibrated, or which is to be calibrated, that will be attached to the tester, and the pressure P is exerted on the fluid by the piston, which is transmitted to gauge when the valve is open. Okay, the fluid pressure may be varied by adding weight. Fluid pressure may be varied by adding weight to the piston, or by using different piston cylinder combination of varying area. Okay, so this is nothing but the fluid pressure may be varied by adding the weight to the piston, means weight of the piston will increases, or above the piston will increases, or by using different piston cylinder combination of varying area. many kinds of pressure measuring devices may be calibrated. Yes, many types of pressure measuring devices may be calibrated as industrial pressure gauges, piezoelectric pressure transducer, and engine indicators. So that will be calibrated by using this deadweight pressure gauge. Okay. The accuracy of this gauge is limited by uncertainties in masses of loading weight and in area of a piston cylinder combination. The friction between cylinder and the piston. Okay, so these are the accuracy of the gauges limited to the following factors. Okay, so this is nothing but the deadweight pressure gauge which is used for the calibration of different gauges. That gauges is nothing but the industrial pressure gauges, piezoelectric pressure transducer, and engine indicators, so which will be used for the major calibration purpose. Okay, then next we will have to study the different types of strain gauges. Okay, the strain gauge is also known as the strain transducer, means whatever the strain gauge is used for the measurement of strain, that will be known as a strain transducer. uh, Device for measuring dimensional change, means the device for measuring dimensional change on the surface of a structural member under test. On the surface means on the surface of the स्ट्रक्चरल मेंबर मीन्स जर स्ट्रक्चरल मेंबर असेल त्याचं जर आपल्याला डायमेन्शनल मेजरिंग करायचं आहे तर त्याच्या सरफेसवर जे काही एक डिव्हाइस प्लेस करतात दॅट डिव्हाइस इज नथिंग बट द स्ट्रेन गेज. नाव द सिग्निफिकंट ऑफ अ मेजरमेंट ऑफ स्ट्रेन गेज आर utility of strain measurement as a mean of determining maximum stress values or in specialized transducer to measure force, pressure, acceleration, torque. Okay, utility काय strain measurementची, that is nothing but determine the maximum stress values, specialized transducer to measure force and pressure, acceleration, and the torque. So desirability to avoid the use of large factor of safety in design of aircraft, automatic control equipment due to mass inertia consideration. Okay, so desirability to avoid the use of large factors, desirability to avoid the use of large factors of safety in design of aircraft and automatic control equipment due to mass inertia consideration. Necessity of experimental verification of strain in complex physical system where strain can only be approximately estimated, even with the most rigorous analytical methods. Necessity of experimental verification काय आहे? That necessity of experimental verification of strain is in complex physical system in human leg and skull, where that strain gauges are used. Okay, the strain can be only approximately estimated even with the most rigorous analytical methods. Okay, then characteristics of the strain gauges. What are the different characteristics of the strain gauges? That strain gauges are cheaper, reliable, and readily available. These are the different characteristics must be purchased by the strain gauge materials or strain gauges. That strain gauges are cheaper, reliable, and readily available. Then negligible mass and extremely small size. Is it? Means the size of the strain gauges must be negligible, as well as the mass of the that strain gauges are also high speed of response and negligible time lag. Means once we have used for measuring the strain, the response of that strain gauge must be very high and negligible time lag in the measuring. Simple and easy attachment to the specimen under test. Means attachment for the measurement of strain gauge will be simple and easy. Capability to indicate static, transient, and dynamic strain. Capability काय आहे म्हणते to indicate static, transient, and dynamic strain. Availability of gauges in variety of types and size suitable for a wide range of applications. Availability of gauges in variety of types, sizes suitable for a wide range of applications. High sensitivity in direction of measured strain. High sensitivity means sensitivity of that instrument must be high in the direction of measurement of strain, but low in transverse plane. Insensitiveness to ambient condition means whatever that atmospheric conditions are there, that will not be means for that the sensitivity of the instrument will be must be negligible or equal to mm, no sensitivity. Okay, so it will not be sensitive for the ambient condition. Okay, means as the it will be sensitive to the ambient condition. What will happen, suppose there will be a very high temperature, suppose there will be a very cold temperature or very low temperature. In that case, there will be the deformation in the reading, as well as what we can say that error will take place in the strain gauges. So that's why the strain gauges must be insensitivity to the ambient condition. Okay, then strain gauge measuring techniques means what are the different strain measurement techniques depending upon the requirement and standard employed. Following are the basic method. First is the photoelectricity strain gauge and brittle lac wires. Okay, 600 micron strain. Then the strain gauge is again classified into two types: non-electrical and electrical. Non-electrical strain gauges are good for static load only, mechanical, optical, and photoelectric. So that mechanical strain gauges are used for the measurement of 10 micron strain, optical used for 2 micron strain, and a photoelastic is used for 40 micron strain. Okay, electrical strain gauges are good even under dynamic condition of loads, then electrical strain gauges are again classified into resistance and capacitance or inductance. Resistance electrical strain gauges, capacitance and induction electrical strain gauges. So in resistance, metallic strain gauge, which is used for the measurement of 0.5 micron strain, then semiconductor 0.0 micron strain gauge, which is used for the small mass and size. Then capacitive or inductive, the large mass and size, rugged construction, retain calibration over long period of time. Okay, so this is the classification. So very first classification is photoelectric strain gauge, brittle lac wire. Here the strain gauge classified non-electrical and electrical. The non-electrical good for static load only. So mechanical, optical, photoelastic, and another type is that is electrical. Okay, again electrical are classified into resistance, capacitance or inductance. Okay, metallic, semiconductor, and that capacitance inductance are large mass and size, rugged construction. Okay, so these are the different classifications of the strain measuring techniques. Okay, then next, resistance strain gauge means what are the means here we have seen the strain gauge type into electrical, and electrical again classified into resistance, capacitance and inductance. So that's why that resistance strain gauges are used to measure the strain of 0.5 micron strain and 0.01 micron strain, that is metallic and semiconductor. Now the resistance strain gauges are again classified into unbonded and bonded. That bonded consists of metallic wire, and bonded consists of metallic and semiconductor. So bonded is classified into metallic and semiconductor. The metallic is again classified into helical wrap wound on a flattened grid. Each foil gauge, wire type flat grip, and wire type oven grid. Okay, so that each foil gauge, wire type flat grid, again classified into single element or grid, then multiple element or grid, that is rosette. Okay, so these are the strain gauge, resistance strain gauge classification. Okay, so in our syllabus we will have to study that bonded resistance strain gauge and unbonded strain gauge, metallic and semiconductor. Okay, so for understanding the resistance strain gauge, we will have to study the Weston Beach network that we have studied in the 11 or 12th standard. Okay, so in the upcoming lectures or next lecture, we will go on through these types of Weston Beach networks, how then the next type is a um, metallic rod will act as a resistance strain gauge, because in the mechanics of material you have studied, means whatever the metallic bar is under tension, we will have, or we have studied that metallic bar which is fixed at one end and free at other end. So on the other free end, the downward tensile force is applied on the universal testing machine, UTM machine, in the mom lab. Okay, so as we have applied the downward force, what will happen, that rod will get elongated by a certain amount, means there will be some deflection or deformation occur in that metallic bar. Okay, so that is nothing but the strain. Okay, means strain is because of the force is applied perpendicular to the cross section of the cylindrical bar, and because of that downward force or tensile force, the deformation will takes place in the metallic bar, and that deformation is nothing but the change in length, means whatever the change in length takes place after applying the downward force, that change in length upon original length of the bar, that is nothing but the strain of that metallic bar. Okay, and Poisson's ratio is what, that is a stress, tensile stress upon what we can say that strain, that is nothing but the Poisson's lateral strain upon longitudinal strain. Okay, as the diameter of that cylindrical rod will decreases, the length of that cylindrical rod will increases, that is nothing but the lateral strain upon longitudinal strain. Okay, so which we will go in detail while studying that thermal conductivity gauge, or what we can say that the metallic rod as a thermal conductivity gauge. Okay, so today we have studied that dead weight pressure gauge for the calibration of what, pressure gauge, industrial pressure gauge, piezoelectric pressure transducer, then engine indicators. Okay, so these are the different types of what we pressure gauges can be calibrated by using this dead weight pressure gauge. Okay, then we have studied the what is strain gauge, what are the significance of the measurement of strain gauge, then the characteristics of the strain gauge possessed by the, or a different strain characteristic possessed by the strain gauges. Okay, then we have studied the classification for the classification of the strain measurement techniques, and we have studied the classification of the resistance strain gauge. So all the types of resistance strain gauges we will have to study in this second part of the third unit. Okay, first part is pressure measurement, um, is it. So after the completion of this unit, I will share you the notes related to unit number 3. In unit number 3, two parts we will have to gone through two parts, means we have completed the pressure measurement, and next part is the strain measurement. So today we have started that strain measurement. From next lecture we will study the what is bonded and unbonded resistance strain gauges. Okay, so we will stop over here. Whatever the doubts you will be after the going through this video, that we will discuss in the Google Meet. Okay, so if you have doubt related to previous lecture, that also we will discuss in the Google Meet after the completion of this video. Okay, so thank you.